Lesson 4.2 is on rational number representations. The learning targets are to define and recognize rational numbers, represent repeating decimals using bar notation, and convert a repeating decimal to a fraction. Vocabulary. We have rational numbers, which are numbers that may be represented as fractions or decimals. This includes terminating decimals, or decimals with a finite number of digits, and repeating decimals that have one or more digits following the decimal point that repeat endlessly. Example A, convert a fraction into a decimal. This you've done before. You just need to take the numerator divided by the denominator. So 9 divided by 11. So, 11 can go into 98 times. So I'm subtracting 88. Bring down a 0, that's 20. 11 can go in once. I get 9. Bring down a 0, it can go in 8 times. 88. I am stuck in a loop. The loop is going to go 0.81818181 forever. So instead of writing it forever, we can use the bar notation. So I can do 0.81, the bar over the top, because the 8 and the 1 both repeat. Example B, convert a decimal into a fraction. So again, we're looking for place value here. So the 5 is in the thousandths place. So that tells me to put 25 over 1,000. 25 can go into 1,000. So I need to take 1,000 divided by 25, and I get 40. And 25 divided by 25 is 1. So 0.025 is the same thing as 1 over 40. And this is where it gets a little tricky today. We want to convert a repeating decimal into a fraction. The first thing you do is let x equal the decimal that's given. And then you're going to want to multiply by a power of 10. So either 10, 100, 1,000, in order to move the decimal just to where the repeating starts. So if I wanted to move the decimal to where the repeating starts, I need to move it one spot. So I'm going to multiply both sides by 10 to make that happen. 1, 2, 3, 4, 5. I want to keep my places after the decimal even, so I can subtract, because that's the next step. The next step is to subtract the 10x minus the x. So we're subtracting those two lines, and we have to do it to both sides. So 10x minus 1x is 9x. 5.11111 minus 0.51111 is 4.6. Now I have to get x on a side by itself. So I'm going to divide both sides by 9. And I get x equals 4.6 over 9. But I can't leave a decimal in my fraction. So I'm going to make it 46 over 90, and I just multiplied the top and the bottom by 10. But now 46 over 90 can actually reduce, and it can reduce to 23 over 45. So this decimal, 0.51 repeating, the 1 is the repeating part, is equivalent to 23 over 45. If I get all of this done and I'm not confident, I check it. So in my calculator, I do 23 divided by 45, and I just make sure that my answer is what the decimal I started with. Because this process is a little bit confusing. Let's do another one. I'm not going to do all of these. I'm just going to do a couple. So I want to convert the repeating decimal into a fraction. It's 0.5 repeating. Again, the first step is to make x equal to 0.55. I'm going to go just like 4 digits. Again, I want to move the decimal. I have to move it at least once to make this work, so I'm going to make it 10x equals 5.5555. So when I do 10x minus x, I get 9x. And then 5.5555 minus 0.5555 is 5. So then I divide both sides by 9, and I get x is 5/9. And again, I double check it in my calculator. I take 5 divided by 9. I got 0.5 repeating. I'm good to go. And then let's do example D. Convert the repeating decimal into a fraction. I'm starting with 6.010101. That's x. This time I actually have to move my decimal 2 times in order to get in all of the repeating. So that's 100x. And 601.010101. 100x minus x is 99x. 601.010101 minus 6.010101 is 595. I divide both sides by 99. I get x equals, let's see, 99 goes into 595 6 times. 99 times 6 is 594, so that leaves me with 1/99. So x equals 6 and 1/99. If you need to practice this, which you probably do, I mean, we're going to do it in class, but there's 3 more right here. So what I would do is pick one and pause the video